Yeah, hello everyone. Today we are going to learn one of the main topic in VLSI, that is the reset. So, what is meant by reset signal? So, reset is used to reset all the devices to initial state. Means in the design there is no such as initial state. It means like output of that particular flop will be zero. So there are two types in reset. One is active low reset. Another one is active high reset. In that also there are types like synchronous reset and asynchronous reset. One by one we are going to learn all those things. So first we are going for active low reset. So what is meant by active low reset? So active low reset is like if the reset signal equals to 0, then the flop is in reset mode, and the reset equals to 1, flop is going to functional mode. Here means it is like whenever we are giving reset signal equals to 0, then the flop output equals to 0, means the q equals to 0, and whenever we are giving reset signal equals to 1 in active low reset, then it is going to functional mode, means q equals to data input. And in active high reset, it's like if reset value is 1, then flop is in reset mode, and whenever we are giving reset equals to 0, flop is going to functional mode. So it's like that whenever we are giving reset high signal equals to 1, then the design is going in reset mode, and whenever we are giving reset high equals to 0 in active reset high, then it is going to functional mode, means the output of that flop equals to data input. So this is the active high reset. Here we are seeing like these things like reset removal, reset deassertion, reset applier, reset assertion. So what is the meaning of that, all those things? So here in these things, what is meant by reset removal? In that reset removal word only there is the definition like reset removal. So whenever we are removing the reset, means whenever we are removing, going from reset mode to functional mode, means we are removing the reset things, then that is called as reset removal. Why we are calling it as reset removal? Because it is going from reset state to functional state, means we are removing the reset signal and going to functional mode. That's why we are calling it as reset removal. Here also we are calling as reset applier. Why? Because it is going from functional mode to reset mode, means we are applying again reset mode. That's why we are calling it as reset applier. Here in active high reset, it's like when we are going from reset 1 to 0, it is called as reset removal. Why? Because we are removing the reset thing, because it is going from reset mode to functional mode, means we are when we are removing the reset signal only, then it is going to functional mode. That's why we are calling it as reset removal. But here we are applying the reset signal. That's why, because functional mode to reset mode, that's why we are going to apply reset things. That's why we are calling as reset apply. And what is meant by reset, deassertion and assertion? In this word only there is the meaning like what is reset deassertion in active low reset. Reset deassertion means we are deasserting the reset things, means we are removing the reset thing. That's why it's calling reset deassertion. This when we are going 0 to 1 in active low reset, then it is calling as reset deassertion, and whenever we are going from 1 to 0, then it is called as reset assertion, because we are asserting the reset things. That's why we are calling as reset assertion when we are going from 1 to 0 in active low reset. But in active high reset, whenever we are going from 1 to 0, then that is called as reset deassertion, because we are deasserting the reset, we are removing the reset. That's why we are calling it as reset deassertion. But in but when we are applying the reset things, when we are going from functional mode to reset mode, then we are applying the reset mode, means we are asserting the reset things. That's why these things we are calling as reset assertion. don't confuse with assertion and deassertion. Assertion means we are asserting the reset, and deassertion means we are deasserting the reset, means we are removing the resetting. That is why called we that is why we are calling reset removal same as reset deassertion, and reset apply same as reset assertion. Yeah, these all are the things in the active low reset and active high reset. So next we are going to learn about synchronous reset and asynchronous reset. Yeah. So this is the definition for active low reset. Like if reset equals to 0, then flop is in reset mode, and reset equals to 1, flop is going to functional mode. Same thing like high reset, when reset value is 1, flop is in reset mode, and reset is 0, flop is going to functional mode. So what is meant by synchronous reset and asynchronous reset? So we already learned about reset removal, deassertion, and reset applier or assertion. So in synchronous reset, whenever the reset removal or deassertion and reset applier or assertion, if these all are synchronous with each other, means when it will work with respect to clock edge only, then it is called as synchronous reset. When means with clock only we can able to reset the clock or design. In my design, suppose there is no clock, then I am unable to reset the things in synchronous reset. But in asynchronous reset, if in asynchronous reset, reset applied if it is not work with respect to clock edge, means it is not synchronous with clock edge, it is asynchronous to the clock edge, then it is called as asynchronous reset. Means without clock also we can able to reset the flop or design. This is the main thing in asynchronous reset. So these all are the definition for synchronous reset and asynchronous reset. Means in synchronous reset, reset removal or deassertion, and reset applier or assertion, these all are synchronous with clock edge. But in asynchronous, reset applier is not synchronous with clock edge. This is the main difference in synchronous and asynchronous. If we go for design for synchronous and asynchronous reset, then it's like here, this is the synchronous active low reset, and this is the asynchronous active low reset D flip flop. So why we are why in synchronous reset, why we are getting output at the next clock edge? Because this is the mux. When reset is applied to the mux output of the synchronous reset, then the diagram then this mux output immediately give the output immediate this mux output will immediately come at this thing, but this output will move to q when this clock edge comes. That's why we are getting output of that synchronous flip-flop at the next clock edge. That's why this because that is in data path. That's why we are getting the output at the next clock edge. So if we go for the syntax for synchronous active and asynchronous active low reset, then this is the syntax for asynchronous active low reset. This is like in sensitivity list we have to give like passage of clock or linkage of reset, then it is called as asynchronous active low reset. And if we go for synchronous active low reset, passage of clock not of reset. This, if this syntax is there, then that this is called as synchronous active low reset. And whenever this syntax is there, then this is called as asynchronous active low reset. So if we give this code to the tool, then this waveform will come. Like here we can see, here whenever the reset is applied, whenever the reset thing is applied, then the in synchronous reset is synchronous with the clock edge, means it is giving output at the next clock edge. But in asynchronous, it's giving output immediately whenever the system is going to reset, means it is it affect whenever the reset signal is going, means whenever the negate reset is applied, then only then immediately the asynchronous reset system will work, but in synchronous it will work with next clock edge. That's why this is the main difference in synchronous and asynchronous reset. So if we go for active high reset syntax, it's like passage of clock or passage of reset high, and synchronous active high reset is like passage of clock reset high. This is the main syntax of active high reset. If we see the waveform here, if we are whenever we are applying the reset signal in reset active high reset, whenever we are going from 0 to 1, then that is called functional mode to reset mode. That's why here this is the reset mode. So whenever the signal is going to reset mode, the output of that asynchronous immediately will affect, but in synchronous it will give output at the next clock edge. So because of synchronous reset is synchronous with removal, reset removal and reset apply, but in asynchronous it is not synchronous with clock edge. It will give output immediately when the system is going to reset. Suppose suppose here, if suppose in this code, if suppose we are giving passage instead of negate, what will happen then? Here we gave here this thing like we gave like passage, keeping passage instead of negate. So what will happen? So why we can't give passage instead of negate? Because we can't give passage in the sensitivity list of active low reset, because the main purpose of asynchronous is without clock also we can able to reset the flow, but we can able to reset the flow, but by seeing at this waveform, it is not possible, because it acting as a synchronous reset, because it is giving output at the next clock edge. So because of that reset at the negative of because of that, if something happens to the clock in the design or something, my design getting hanged or my clock is not getting derived properly, then this is not work as definition of asynchronous. That's why we can't give negate instead of we can't give passage instead of negate. That's why we are giving a negate here in the active low reset. Same as for this thing also, active high reset. We can't give negate reset instead of passage, because it uh, can't work as asynchronous. It is working like same as synchronous reset. So because of that we can't give negate reset instead of passage reset. So if we are seeing all this explanation, there are some question is like why mostly in design we prefer like active low reset. Why we prefer active low reset? Because of in the most design we prefer active low reset, because here if we see here, if we are going from reset mode to functional mode, anyhow here we require power, because we are going from reset mode to functional mode. So it is require power. And if we are applying the reset thing, it will not require any power, because it is already going to reset mode. For reset mode we need not to worry about any power, because it is already going to reset mode. Means when it is going for 1 to 0, means the reset mode, there is no power. If power is also not there, it automatically go to reset mode. But in active high there is concept, this is not applicable, because if we are going from functional mode to reset mode, means we are going from 0 to 1, we require power to we require some power for reset mode, because we are going from 0 to 1. So this is not comfortable, means this is not good sign, because if we are going for resetting, we require power. So the most prefer because of that only we prefer active low reset, because if we are require power for resetting the thing, and suppose if something happened to our design, if power is not there, then this function is not able to work. That's why we mostly prefer active low reset. So because we need here power to go for 0 to 1 for reset things, that's why we are prefer mostly active low reset. And here and also one more thing, why we prefer synchronous reset over synchronous reset, because the if suppose something happened to my design, like my design is not properly driving clock, or my system is got hanged because of that clock is not properly going. So because of that because the functionality of synchronous reset is like with clock only we can able to reset the system. And in the synchronous reset, if you want to reset the system but clock is not available, then you can't reset the system. And suppose like I said already, if suppose my design is not working properly or hanged, and my clock is not driving properly, then the synchronous reset can't work properly, because to give output synchronous reset need next clock edge. But in asynchronous reset we can't we can reset the system without clock also, because whenever we reset the system, it immediately affect the output of that system. So because of that only we prefer a synchronous reset over synchronous reset. Yeah, thank you.